Live now. I think we're ready. All right, welcome back. It's Game 2014 in the fall 2020 semester at George Brown, and we are Mobile Game Development 1, Week 5 of our broadcast, Part 2. We just talked about our Assignment 1, Part 2 details, and now we're finally going to get into the kind of the meat of what we're talking about today. So again, we're sitting at here, optimization for mobile, and let's talk about a couple things. So Assignment 1, Part 2 has been released. It's due at the end of Week 7. That's on Sunday, October 25th, 2020 at midnight. Lab 3, Object Pooling, has also been released. That's due by the end of the week. So please follow along to have that done. I had a question today that says, there's very little details around Lab 1, 2, and 3. What do you want us to do? Attend class is the answer, and then follow along. If you don't follow along, you don't attend class, then you really can't complete the labs unless you talk to somebody. So that's what I would like you to do. And really what it is just a code along where you do what I do. All right. So that's what Lab 3 is, practice, and you see some techniques that we talk about together. We're also going to test 1 results. That's something that is we got to talk about. It was an easy test. The average was about 85% for those people who wrote it. For people who didn't write it, there's not much I can do for you at this point. But I believe you lost some easy marks here in this case. So then we're going to be talking about a few things now. We're going to talk about a design pattern review. You guys should know about design patterns, so we'll talk about them again. And I'll treat it as if, excuse me, you've never done design patterns in your life. And just to get a hand or some check marks, does anyone in our who's attending not know what a design pattern is? Can you put your check mark in the participants panel if you don't know what design patterns are? Okay, Emmanuel, no problem. And that's okay, because there's some people who are returning students, or whatever, or maybe you haven't had a chance to see some of the other courses that have been updated and refreshed, where we do talk about design patterns a little bit more. Okay. So we're also going to be talking about something called optimization patterns, and one of them is going to be called the object pool pattern that we're going to be using. And you should have known about object pools. How about this? For object pools, who does not know object pools? And Emmanuel, I know you wouldn't know because you didn't put your hand up for the other one. Does anyone else not know what object pools are from the people that are here? Anyone else? Lawrence? Okay, thanks, Lawrence. Well, we'll talk about it. No problem. It's not a big deal. I'm going to assume that you don't know. How about that for everyone that's here? We're also going to revisit game objects and how they work and how it works with prefabs, and we're going to do a bit of an object pooling demo. Kind of, yes, Lawrence. Kind of like loading assets ahead of time, but that's only one part. All right, let's talk about what are design patterns. So as game developers, we see a bunch of situations where we want to develop code and we want to solve a problem. And the thing is, a lot of times the problems we want to solve has already been solved. So instead of reinventing the wheel, we should access this kind of repository of knowledge that's out there, and for these proven solutions and that already exists. And these proven solutions are what we call design patterns. All right, so they're just a way of coding. It's an algorithm a lot of times, or a pattern that's object oriented that we use to kind of create code. So really, it's a proven solution that's already been that we're taking from someone's experience and we're applying it to our situation. That's what we're doing. And apart from describing what the problem is, because that's a lot of times what patterns do, they also describe the solution, right? So they say, well, here's a typical problem that you might run into, developer, and here's some solutions we found. Okay, there's a community of people that do that kind of stuff. One of the earliest books around design patterns that we're talking about is called Design Patterns: Elements of Reusable Object-Oriented Software, written in the 90s by some people called the Gang of Four. It's now a very famous book, and why? Because a lot of our software engineering design patterns now across all software engineering disciplines, not just game development, use design patterns, especially object-oriented, when object-oriented design for software. So that's what they use here. And usually what we have is the pattern usually has some kind of template, and these pattern templates have a name, okay? And that name is something that we access. So a good example is there's different kinds of pattern. There's creational, there's behavioral, there's structural, and there's optimization patterns. And one of the ones we're going to be talking about today is an optimization type design pattern. So, I mean, currently our desktop hardware is pretty rocking. You know what I'm saying? You can pretty much, you know, from if you want to download and install the average software that's not graphics related, right, as an example, and if it's not game related, our hardware is awesome. You know, we can, for most modern hardware, you can handle almost any software that people make. Okay, and memory optimization is not really something that people care about so too much if it's not something related to game development. Game development, on the other side, really challenges, you know, software engineers, because game development, there's a lot of calculations that go on every frame. A frame on average being 1/60th of a second, or 16 milliseconds. We have many calculations happening during that time frame. And the fatter our objects that we push around are, you know, or, you know, as an example, the bigger memory footprint they take, then it becomes, our game kind of drops in performance. So instead of our game dropping in performance like that, we want to have consistent performance. So we want to optimize. And it's even more prevalent in mobile games and mobile consoles like the Switch. You only have a limited amount of memory. You have a limited amount of resources, and we want to optimize them. So some common design patterns that we're going to use speed up the game, and one of them is called object pools. And what object pools do is they avoid unnecessary memory allocation to reduce something called memory fragmentation. And what memory fragmentation does, right, and we'll talk about this in a second, is it can provide issues. So let's talk about this example. We want the intent for the object pool is to improve performance and memory use by reusing objects from a fixed pool instead of allocating and freeing them individually. Right. So here's an example of that. We have an object. Here's our no pooling. We fire some bullets, and when they leave the screen, right, as an example, we destroy them. So we instantiate, destroy. This is a typical thing that you might be used to doing. Or we have another option. Here's object pooling in place. I have an object. I shoot my bullets. As an example, when they leave the screen, they get put back into the object pool. So we never destroy, we never instantiate or destroy these objects. We just reuse these objects over and over again. And we can use different structures for this, and one of the most common structures we're going to use today is called a queue, which is kind of a great structure in C# that helps us do this kind of thing very easily. Okay, and if you don't know what queues are, think about a lineup, right? I have a lineup of people at a bank or at a ATM as a good example. So they're all lined up for the ATM, and then the way queues work is first in, first out. So first come, first serve. That's the way queues work. So the bullet at the front of the line is the one that we're going to call to use. The bullet at the back of the line is going to wait and be inactive until we're ready to use it. Okay? As soon as the bullet in the front of the line is called, as an example in the beginning of the queue, we're going to dequeue that bullet. It's going to leave the bullet pool. It's going to become active, and it's going to appear on top of the player object or near the player object. Okay? When it leaves the screen, what's going to happen is the bullet is going to become inactive and put itself back into the pool, and so it can be used again and again. Okay, that's how the bullet pool would work. There's many ways of introducing bullet pools, and there's other optimizations. So we're going to do two things today. One of them is kind of introduce a bullet pool, and the other one we're going to use is some kind of background image that we're going to reuse, a reusable background for scrolling. Okay, which we've seen before. I'm going to introduce it again in Unity and see how easy it is to do in Unity this time. All right, so that is object pools. And so really this idea is it's all driven by the curse of fragmentation, which is, you know, you have a small amount of memory, and what happens is every time we instantiate and destroy, it leaves these pieces of memory in the heap that are empty, right? And these empty areas in the heap can't be reused because sometimes they're too small, especially if you don't have contiguous memory segments. What that means is memory that's the same size. So example, if I have an object that has a larger footprint that I'm instantiating, and I just deleted an object or removed an object from memory that has a smaller footprint, I can't put the larger object in that space, right? So I have a slot that can't fit anything, right? So we get something that looks more like this, where here's the heap, initially empty. We add an object as an example, and then we add another one, which is slightly bigger than this one, right? And then we delete the first one, right? Which we have two fragments, one here and one here. And then I want to add another one this size, and well, there's not enough room to put one here or one here. And so what happens is you get this fragmentation happening. You get these spaces here in memory that can't be used, right? And again, we have this problem is prevalent mostly in video games, but it also works for graphics manipulation, for graphics programs, software engineering. If you were going to make a new Photoshop or something like that, or anything like where you're allocating large amounts of memory, then this also is something that you want to be wary of. So what's the pattern? So again, we're going to define a pool class of some kind. We can do a pool class or a pool structure. We can do that. That maintains a collection of reusable objects. Each object supports an in-use query. In our case, instead of it being alive, we're going to say that it is active. This is a generic words here that can work for any situation, not just in Unity. All right, so some kind of pool of objects. And when the pool is initialized, it creates an entire collection of objects at the front. And Lawrence said, do I pre-allocate assets ahead of time? And the answer is yes, you do. You load up assets ahead of time, almost like a preloading step. And once you've loaded all your assets, by the way, this also works for sound assets. Okay, sound assets. When the object is no longer needed, I send it back to the pool, right? And this way, no objects are created or destroyed. I maintain the exact same memory footprint all the time, and they're all in contiguous memory, right? So all I do is return an object back into the pool, as opposed to create new objects and allocate more dynamic memory. So I'm not allocating dynamic memory. I'm going to try and reduce that when it comes to my game. So when am I going to use it? Well, it's widely used in games, and same thing with sounds, not just images, but you need to, this is where it can be used. You need to frequently create and destroy objects. So this is kind of a case. I want to make a lot of objects, like bullets are a great example of something that, of a bullet pool that I want to use. Objects have to be similar in size. So they have to be bullets, all bullets, the same kind of thing all the time. Enemies, as an example. Allocating objects in the heap is slow, or could lead to memory fragmentation. And guess what? On a mobile device, allocating objects on the heap is slow relative to everything else, right? And then the other option, and we don't see this a lot here, we won't see it this semester, is each object encapsulates a resource such as a database or network connection that is expensive to acquire and can be reused. So some kind of packet that we don't want to, recreate this packet because we're going to instantiate or establish an object. We want to change the properties of the object, but we don't want to instantiate a whole new packet, as an example, in a network scenario. Okay? So these are the conditions where we want to use object pooling. Questions around this? So this will be on the next theoretical test. The next theoretical test that you'll get will include these things. It'll be a slightly larger test than Quiz 1. Quiz 1 was kind of like, hey, here's some things about mobile. Quiz 2 could be including stuff like this. Okay, speaking of which, before I move on to the demo for today, I want to also mention just our structure where we are today. So we're sitting at week 5. I know I jumped back to this, but I also have to mention that by week 7, so in 2 short weeks, we're going to have a practical test that's going to be running through the week. So there's going to be a bit of a conflict. One conflict is going to be you're going to be working on assignment 1, part 2. Plus, in week 7, you're going to be working on a practical exam that I'm going to give you most likely at the beginning of the week, and then you'll have until the end of the week to complete. Like in class, single week kind of exam. All right. Again, one thing I can't give you, it can't be as big, obviously, as your game. It's got to probably be a single scene, chances are, or if I want to make it bigger, I'm going to give you a template. I might say, here's a template, don't start from scratch, add to it. Because this way it'll save you time, all the time that you would have developed to make that template. The other thing I'll try and do as well is give you assets. I might say, look, here's some assets so you don't have to go hunt for your own. You know, as an example, use these ones. Everyone's game should be the same, you know, kind of thing. It'll be individual, and again, it'll be worth quite a bit of marks. So please be wary of this, because if you think about this, there's 25% for my my assignment 1 part 1, assignment 1 part 2, right? There's 20% or something thereof for your, if I'm not wrong, for your for each of the labs together combined are 10 labs, and this, we're at lab 3 right now. So 20%, let's say, rough, right? So if it's 50 and 20, that's 70. That leaves 30 left, which means our each of our tests is 15%, right? Or all of our tests are 30%, as an example, and 30% means both the theoretical tests plus our you know, our actual practical test. And we can go through that again as we get closer. So I'm guessing that our theoretical test is worth 5 and our practical test is worth 10. So again, if you did really well on the theoretical test, awesome, but it's the practical test that's going to be weighted more. So make sure you know what you're doing. You need to know Unity to do this test. You need to have access to Unity. You need to have access to your some kind of simulator or a device that's working, all right? It could be BlueStacks, it could be Genymotion, it could be Nox, it could be an actual device. But you need to have something like that to test your code with. You will be recording a video again, but again, it'll be like 5 minutes, and I don't care about you know, video quality in terms of like making it a professional video. I do need to hear and see your screen. And one of the challenges I had when I was previewing some of the submissions that you guys made on Sunday was that there are some people who didn't really do any quality control in their video, and I can literally not see the screen. The screen is like pixelated, right? Make sure if your screen is pixelated, check that video. I may come back to you and say, can you give me another version of your video, because I can't see your screen or I can't hear you. It might be like that. And if you can't provide that, then you'll lose your video marks, right? So please don't do that. That would be very bad. All right, any questions around the structure before we move on to the demo? Talked about a couple things here: optimizations, design patterns, as well as object pooling. All right. All right. Doesn't seem like we have any questions. Moving on to the demo now. Okay. And you might say, wait, Tom, that's a lot of time for the demo. And how did you run out of time with the other class? Yeah, it's Unity, and things can go well and not so well. And we're also dealing with mobile, which is another twist. Okay, let's do this. So let's put on our video. So people who are watching, this should be available now to you as we move forward. So some people may want to watch this video remote, and that's totally fine. Let's see how that is working. That's not going to be the name. That is going to be a video. Yes, it works. And let's submit that. Okay, so there's that video that we're working with right now. This is the one that's live that we're going to be working with. So for people who need to see it, please make sure you take a look at this. All right, so we're going to pull up our Unity Hub. Let's pull up Unity Hub. So I'm going to make a new project. So I'm going to make a new. I'm not going to use the one we had last week because there's some. I don't want to touch what we did last week. I want to leave it and make it something separate. So let's go to new. I'm going to choose that. Notice that at the top it says 2020.13F1. For your midterm test, you need to have at least a Unity version of 2020.13F1 or greater. Okay. I'm going to call this project GAME2014 in the fall 2020 semester. And it's going to be Lab 3B because you guys are the B team. It's going to be saved in the same spot, create. And what I'm going to be doing while I'm pulling this up is I'm going to make a project that's mobile compatible. So maybe you guys can get there before me. I'm going to make a project that has the assets that I have up on Blackboard. So that means these assets right here. So make sure you get those assets and put them in a textures folder, right? I'm also going to be using Genymotion, so that's something that I want to push towards, and I'm going to put this up on GitHub. So I'm going to get all that going. Let's wait till this comes up. All right, cool. So there's my project. Remember what we did last time? We need to go to Window, just in case you've never seen this before, Package Manager. Under Package Manager, we want to go to this little gear icon, and we want to go to Advanced Project Settings. We want to add or enable preview packages, right? You need to do this during your test as well. And we're going to update some of these packages while I wait for you to load Unity. Some of people are going to have slightly lower loading times than me, and this is going to give you guys a chance to catch up while I do this. Some people will already be done and waiting. Please bear with me, and we'll get there. Okay, we're getting there. Timetable. All I'm doing is I'm updating my project so that I don't have anything that's old. And this way, if you have a newer version of Unity than me, then yours will work with mine. And you don't need to update any of my packages. They'll be the latest version. Okay? That's why I'm doing this. And if you're watching the video and you've already done this optimization, just skip ahead. Cool. So I've updated my packages. Fantastic. And then what I want to do is I want to go to File, Build Settings, and I want to change to Android. So let's do that. So switch platform. This will take a bit of time. Some people have already been done. Please bear with me while I put this together. Okay. And cool. All right, this is finally loading. And all it's doing is translating assets that we have here from kind of regular desktop mode to Android mode. I'm going to go to player settings now and configure this. This is the next part. I'm going to change my default company to George Brown. And my project is going to be called, my product can be called Lab 3, 3B. Yours can be called Lab 3. I also do not want to have landscape left, landscape right, just portrait for this one. So I'm not going to make it responsive. That's why I'm making a new project. I also want to go to Other Settings and scroll down, and where it says com.georgebrown.lab3d, I'm going to make it ca.georgebrown. I'm also going to change from the scripting backend that's mono to IL2 CPP and a .NET Framework 4. Okay. And that really should be it. I'm going to close this off, the player settings, at this point. All right, cool. Now, what I want is I want to connect to a device, but I don't have it. Let's bring up Genymotion. Now, you can use any device you want. I've already configured Genymotion ahead of time, so it's working for me. I'm going to play my Samsung Galaxy S10 virtual machine. So these are all the kind of startup, process that you'd have to go through to start a new project and all that stuff. Cool. So we have Genymotion. It's kicked up a new Android simulator. I'm just going to move this a little bit smaller so we can see it. I'm just going to go back to Unity for a second and close down the Genymotion interface. Just leave this up. And on the Unity side, I'm pretty good. I'm not going to build yet. I'm going to close this build settings down. And I want to configure my layout. My layout, I made a layout from before called Portrait last week. And if this isn't working for you, like it doesn't work for me, why? Because I haven't selected, let me go back to default. What I want in my game is to make it so that it uses a the device, not, notice it says game and free aspect, right? And that's bad. If it's showing that, it should show the other stuff. So if I go to my tall layout, as an example, and I go to my game and free aspect, it's not showing me my my device manager because I never chose it. So go back to window. I'm going to go back to my my package manager, and notice in my, I want to go into my Unity registry, and in my preview packages I want to select my device simulator. And some people have asked me that, like, I can't see my device simulator. Well, maybe you didn't add it. You need to add your device simulator in there, or else you're not going to see it. This is an extra package that you need to download and install. Again, I did it kind of in reverse order this time around. It doesn't really matter. As long as you add it at some point, you're good. Okay, cool. It's been added now, and we should be able to do, from our game, we should be able to say simulator, right? But I want to go into my portrait, my defaults. This is what my portrait would look like, and I set that up last time. So this is what it's going to look like this time. So there's my scene. Cool. I want to rename my stuff. Before I put it over on the simulator, I want to rename my structure and change it around. So I'm going to say underscore scenes. I'm going to rename my scene that's inside scenes to, in this case, main. There's my main scene. I'm going to reload it. In my assets, I'm going to make some folders. We've done this before too. My first folder is going to be scripts. And then I'm going to make a folder called textures. And then prefabs. Okay. So scenes, scripts, prefabs, and textures for now. This is pretty good. I don't need more. I could add more. I'm not going to. All right, let's add in my textures. So in my textures, let's add that in. So we're going to add this as my first iteration. So again, the textures can be found up on Blackboard under Sprite Assets. So please make sure you get them. The way we can add textures in Unity, like as you should know by now, is what we want to do is we want to drag and drop from our textures, as an example, and mine are yes, in here. Just going to drag and drop them. You can't see, I'm just drag and drop them from a folder onto my screen here. Drag and drop them, and then you'll see my textures come up. I'm going to put it on a mobile device. These things will work okay on a desktop, but I know that all of these textures here are going to be anti-aliased. I want to take off the anti-aliasing altogether by selecting all my textures here and going to filter mode. I want to go to point no filter. And then click apply. By the way, there's special ones you can use for Android. If you want to override the size of your footprint for memory for Android, you can do that. You can also change the type of filtering and the type of packing. Okay, let's go back to maximum size is 2048. All right, so these are all now point no filter. That's what they are. Yeah, that's important to note. So I selected them all and I changed them to point no filter. Awesome. Let's go back to the scene, and in my main camera, I want to change the color to solid black. Okay. And I want to save my scene. Now, if I was to push this over to Genymotion, it's going to be like, wait, Tom, it's like my Genymotion's black. I don't know if anything happened. Yeah, you're right. So let's add something so we can test that. So we're going to add a new UI TextMesh Pro element. When I do this, it's going to ask me to install TextMesh Pro. I'm going to say import TMP essentials. You should see that. And it's going to add an additional folder in your assets called TextMesh Pro. Right here. We can close this off now because I'm not going to import TMP examples and extras. All I want this thing to be, this Text Mesh Pro is just something that says my game started, right? And notice that it's like abstracted, so it's like way over here. Remember my when I do anything like this, my canvas is abstracted, so it appears like way down here, like you can't really see it. This is the way we do it in Unity. So instead of this, what we can do is we want to make sure that this object is a couple things. One, we want to make it 1440, and we'll make it by something like I want to make it like 120 high, and I also want to make it center. So let's put it in the center. We can do that in a couple ways. If I click on this little transform, if I press Alt, I can choose the center, and it'll just zap there, right? Then what I want to do is I want to make sure that the that it's bigger because we can't see it. So we'll make it centered. We'll make it centered, and we'll make it the size of it like 80. So you can say like game started. I'm not going to use this thing later. It's literally just for I know that the so that Genymotion has taken my app, right? Otherwise, I'm going to get a black screen, and I'm going to make assumptions that it's there, but I don't know for sure. So this is why I'm doing it this way. And we'll disable that later. Okay, so now that we know this is good, we're going to put it up to Genymotion. If it goes there, we're going to shut things down, and then we're going to put it up on GitHub. Let's do that next. So again, we're going to go back to File, Build Settings. And in Build Settings, we should be able to see our device now. Okay? If you've configured everything properly. I'm going to click on Build and Run. It's going to ask me where. I'm going to make a new folder called Builds, capital B Builds. And inside the Builds folder, I'm going to make an APK called Lab3. Okay, now that I've got this, and it's building, let's bring up Genymotion and see the effect. We should see game started, right? That's what we're looking at. And this is a review of things we've already done. We've already know how to do this. I'm showing you yet again so that you've seen it again, right? Again, this is something you should know how to do. We've been doing it week after week. This is the 5th week you've seen something like this, right? If you've attended lectures or you've watched the video. And you can see it's taking its time. It might be done for you, or if you've skipped ahead and you know what's coming, or if somehow you wanted to use last week's project and you ignore what I said, then you're done. You're just waiting for me to catch up, which is okay. I'm in a good position there. If you're waiting for me, it's better than if I'm waiting for you. Right? And again, if you've already done this and you're watching the video, skip ahead until it's done. And when we're at the Gradle project piece, that means to me that we're very close, because right now what's happening is it's constructing it for us and creating the APK and then pushing it across to the Android device. And you can see now that game started. Okay, this is a great start for us. So what to do? Now, if you're here with me, and let's just say hands, or not hands, check marks if you've done what I'm done. If you're with me, check marks please. And if you're not, X, just to indicate that you just haven't been able to do it. And there's still, I've only got like 4 responses out of 15, and okay, no problem, Michael. It's in the participants panel. In participants panel, you pull that up, and then you can add a check mark. Yay! There we go. All right, so thank you for that. I'm going to move on now because most of you have it. I'm going to turn off Unity, but first, before we go there, because turning off Unity like this would be very bad, I'm going to save my scene. Save my scene. Oh yeah, look at that. Look at that. Look how Unity crashiola on me, right? And this is what I had earlier today where I crashed. And luckily it crashed now and not earlier. I'm totally fine with this. It happens sometimes with Unity, especially when you're working with mobile devices. I'm also doing multiple things at the same time. So this could be one of the reasons why this is happening. I'm not concerned overly because it does happen. But meanwhile, if you're like me and you've had a crash, some of the fixes might be downloading a more recent version of Unity. It's totally fine. So far, we've been pretty stable up until today for me. I'm just going to bring this up one more time to make sure that our scene is the way it's supposed to be. Unfortunately, what's happened is my game started, which what you're seeing here is not going to be part of my default scene because as I was saving, oh, there it is. Cool. I want to make sure that I save my project too. So save my project and let's like close it off again. All I want to do is make sure that it was saved properly. It looks like it was. All right, now the other part, which is if I bring up Unity Hub, it tells me where Unity is. So show in Explorer. Here it is. Here's Unity. And what I can do, I'm going to keep Unity Hub up for a second. What I can do is I'm going to use my command line tools. You might use a tool of your choice that you're going to use for GitHub. I always use command line. So I'm going to go to command line tools and I'm going to CD. Made this a little bigger for you guys now. And because I got complaints, it was too big, too small. Drag it in there. And we're going to see that we're inside the Unity project. Now, we need something online where we get a git ignore file. So if I go to github.com and if I go to George Brown College, right? Not the SDL engine, just the George Brown College link. And if you look there, last week we had 2014 Lab 2B, right? We want to go there and we want to grab this git ignore file, like the contents of it anyway. So just grab this, copy all, or Control A, Control C. And I want to make a brand new git ignore file locally for myself. This is important, right? So again, bringing up our code. Here it is. In Lab 3B, we don't have a git ignore file. What I could do is I could make one. So let's make a new one. So new, and if you don't have this, a new text document. If you didn't have the other stuff that I have, if you have the other stuff, just copy paste from the other one. And I'm just going to double click on my git ignore file, which should bring up a notepad or editor, and then Control V. Let's try that again. Control A, Control C, Control V. And there's my git ignore file for Unity, right? And now that I have that, in preparation, I'm going to make a brand new repo up here. I'll do it the other way around this time. I'll say add a new repository, and we'll make a new repository on George Brown. And we'll say that it is going to be called GAME2014 in the fall 2020 semester, Lab 3B, public, which creates a structure, a container for a repository up online. And we've seen this before. I'm going to go back to my command line now and start it going. So if I do a dir, you can see now I have a .gitignore file, which is good. Git init is the first command. Git add dot, second command. Git commit -m, initial commit. These are things you've seen before. I've created my local repository now. What I want to do is I want to cut my other stuff. And that didn't work the way I wanted it. Let's try that again somehow. Crash Analytics. I want to go up here and grab these last lines of code, these ones here, up of my up on my repository, copy them, go back to my command prompt, and right-click and paste. And that should work exactly as you'd expect if you've set your command line up properly. Now, you don't have to use command line. You can use any tool you want. Tortoise Git. You can use source tree, Git Kraken, name your favorite program, GitHub Desktop, whatever you want. I'm not going to specify the type of connection or client you use. And up online, if we refresh, we now have our repository and its initial state. Great. Let's continue with our craziness.
Tom,
yes.
Sometimes when I set up the repositories, it'll give me a notification that it uses Git LFS.
Yeah.
It doesn't always happen though. Like, should we just ignore that, or?
Yeah, ignore it. It just means that you push something that's pretty big.
Oh, okay.
Somehow, or you didn't include a git ignore file, and so it's pushing like some kind of large texture.
It has the git ignore.
Yeah, it depends on what you've done though. If you make it so that the object is like massive, like maybe something like more than 100 megabytes, like a single texture, it'll give you that warning. Anything that's larger than 100 megabytes, it'll complain about. All right. So cool, we've done this, but then we have to relaunch our Unity. So let's do that. Let's go get back in there. So this is a good practice, what we've just done. We've got our base project, and what we want to keep doing is iterate from here, right? We don't want to mess up, work a little bit, then have Unity crash. That would be very bad. And it happened to me today, actually. I was like talking. I was like, hey, let's save everything. And by the time I went to save, Unity crashed, and I lost a bit of my code. That's why I was a little late. So I don't care about my event system or my canvas. That was just for testing this, right? That's what I did there. I don't really care too much about that. I'm going to go back to my scene for a second here. And I care about my scene now. So this is the scene that I care about. I want to put in a background. So the first optimization we're going to put in, we're going to make a scrolling background. And I'm not going to instantiate a new background. I'm going to reuse it. And we've seen this optimization before if you've been with me. So I'm going to go to Textures. I'm going to go to where it says Space Stars. I'm going to drag and drop my Space Stars texture into the background. Right now, it doesn't look like much. It's pretty small, actually. But Space Stars, we're going to change the name of that to say Background. We're going to rotate it by 90 degrees. So on the rotation, on the Z rotation, change the value to 90. All right, so there's our Space Stars. I'm going to change the scale to 3 on the X-axis and on the Y-axis. So it kind of is the same size as the Y-axis, but it's a little bit shorter on the X-axis, and that's okay. That suits me fine. But we can't really see this texture, and it'd be really nice if we had a border temporarily. And to do that, to promote that, I'm going to go down in here into my hierarchy, and I'm going to add, this is a trick, we can take it away later, I'm going to add a new 3D object called a quad. All right, so go to add a quad. Here it is. Let's center it. I'm going to go back to the quad and reset it so it's in the middle. And I'm going to change the scale of my quad. So I'm going to go from a scale on the X-axis, I'm going to go to like 4.7. And the scale on my Y-axis, let's make it 10, which is going to fill up my quad. So again, are you with me? I added a background. All I did was I dragged the Space Stars in there, made it renamed it background, changed the scale. Well, first of all, rotate it to 90 degrees on the Z. Change the scale to 3, 3, 1, right? And then I added a quad, and the quad is a 3D object. The scale is 4.7, 10, and 1. Okay. Now that I've done that, I want to make the quad a child of the background. So let's put that underneath the background like this. You can see that the quad now is indented to make it the child of the background. I want to add a script to the background, so let's add a new script. All right, so I'm going to go to Scripts. I'm going to add a new C# script. We're going to call this background controller. Here's my background controller. I haven't connected it yet. I'm going to do that now. I'm going to click on the background and go Add Component, Background Controller. All right, so now my background controller script is attached to the background controller game object. Cool. Let's double click on the background controller to talk about what it's going to do. Well, what I really wanted to do, first of all, let's talk about background. Let me add another one for now. So Control D, Let's add another background. I've copied everything, right? And we'll call this background 2. Right? I'll leave background as background for now, and you'll see why. So here's background 2. Background 2 still has the background script. But what I want with the background 2 is if I take my move tool and I move it, I want my background 2 to be just outside the screen. And if it looks like it's around 10. Let's make it 10 units exactly. Well, of course it'd be 10 because my quad is 10. So I'm sizing where I'm going to move my background, right, which is just a bunch of stars, way up here. Okay, so that's what's happening here. So I've got 2 backgrounds, this one and this one. But notice this position here. This is the position that I want to reset every background. So what I want to do is I want to scroll down the screen. When I get to the bottom of the screen, I want to reset to back up here. And I want to keep doing that for each of the backgrounds. Keep doing that over and over again. So I have a never-ending scrolling background screen. All right, in order for me to do that, I need some controls. Let's go into the background controller. And again, we've done this before. We're just doing it in Unity again. For some people who haven't done this, yay. Let's add in a public float that we're going to call vertical speed. Our vertical speed float is going to basically tell us how fast our background is going to go downwards, right? And I want 2 methods to help us do that. One of them, let's make a new private method. Whoa. Come on, Visual Studio. It's using ReSharper, and I don't want it to use that right now. Private. Wow. Oh yeah, it's still suffering. Private void, we're going to have a move script, a move function. I'm using underscore to denote private in this context. I'm also going to do a private void check bounds, checking the boundaries, right? That's what that's going to do. And my check bounds script is going to check to see, my function is going to check to see if my object is underneath my screen. Again, these are hard set values. We're not accommodating for screen being a different screen. That exercise was last week. Okay. Here we're just saying we're assuming that the phone is the exact same, just for demonstration purposes, so you understand the concepts that I'm trying to talk about here. So we don't muddle the waters with extra stuff, right? All right. So move. I'm going to call move every frame. So I'm going to move my object every frame, and I'm also going to call check bounds. I don't know what that looks like right now, but I'm going to move and then check bounds. And what check bounds is going to do is it's going to check if the background is lower than the bottom of the screen, then reset. That's what I want this thing to do. I don't have a reset function, so let's add that in. So private void reset. There we go. So check bounds is just going to call reset if my transformed up position on the y-axis is less than or equal to, right, some value, right? And we don't know what that value is, but I'm assuming it's going to be 10, negative 10. And let's go put in the boundary value. So public float, we'll say vertical boundary, right? We'll call it vertical boundary. And that is the object we're going to put here, vertical boundary. All right, so if my transformed up position for this object, for the background, transform is the component that has position, rotation, and scale. Position is a vector 3 object, y-axis. If it's on the y-axis, the vertical. If it's less than or equal to vertical boundary, then we want to reset, whatever that looks like. Okay. And for the reset function, we're going to say that it's going to go back up to positive vertical boundary, right? So vertical boundary should be a negative vertical boundary. so the bottom of the screen. And we're going to reset to the positive vertical boundary. So we're going to say that, okay, we're going to reset. So we're going to say that transform dot position is equal to a new vector3 object. We're going to pass in x on the x-axis, 0, and vertical boundary on the y-axis. So that's going to reset us. So it's going to go down the screen and it's going to move up to back up to the top, wherever that is. All right. The move function is going to use the vertical speed, and it's going to just add on to its transform. So it's going to say something like this: transform dot position plus equals to a new vector3 object that we're going to add in, which is going to be a we're going to not change the x-axis because x is right and left. We're going to change just the y-axis, which is the vertical speed. And we don't want a plus equals, we want a minus equals because we're going to down the screen. And that's our code. So again, we're going to say that we're going to reset. We're going to move down first. Move. We're going to keep moving as we hit the boundary. We're going to check our boundary. When the position of the y-axis is in the negative boundary, we're going to reset. We're going to call this, and it's going to flip back to the top really quickly, right? And it's going to keep doing that forever and ever and ever. We don't need the start function, which takes up cycles. Let's get rid of it. Okay, we do need some values here, and those values are going to be given to us in the editor. Let's go there now. So back to Unity, it's going to compile. And inside of my background, my first one, I want to change my vertical speed to something like let's try 0.1. And my vertical boundary is going to be 10, because we measured that already. We need to do the same thing for background too, because right now we don't have prefabs. And my vertical speed is 0.1, and my vertical boundary is 10. Great. Let's test this whole thing by saving it. We'll save it, and we'll test it in the simulator. Let's see what this looks like. So press play. Way too fast, but it kind of works, right? All right, let's do much slower. Let's say 1/10 of that is what we probably have to move. So again, it's 0.01, and the background is 0.01. Wonderful. Let's test that. Much better. And it's going to go like that forever. Again, things that we're not doing. We don't care about the safe area at this point. Remember, we're not modeling the waters like that. Okay? Should we times the speed by the delta time in the update? Not really. You could if you want, but right now for our example, Michael, not required. If you want to move it differently and you want to make it so that it's more deterministic, our movement, you can totally do it that way. I'm not going to. All right, now the big test. I want to push this to GAME2014. Will it work? Right, so let's go File. First of all, let's save. Save the scene. File, build, and run. And if we did everything right, then in GAME2014, we're going to have the same thing that we see here, which is what the test is. One thing to note is I got a quad, and the quad is like, we need to hide that quad, right? But let's see what happens on the GAME2014 side. Do we actually see that quad? Is it black? Does it impede us? What does it look like? It will look different when we take the quad away, all right? Because the quad is just for sizing. That's all it is. And you can see that it's pushing this around. If you're watching the video, fast forward to when I pushed it to GAME2014. All right, and let's take a look while it does it, pushes over, and Pretty cool, right? We've got our stars, and they're going a little bit slower on the virtual machine that we had on our device, on our editor, and it makes sense that it would be. Cool. All right, it's gonna go forever. It looks like it's working out, and the quad's not really bothering us too much, but it actually is taking memory, which we don't need. So let's stop this, and let's just put it in the background for now. Okay, cool. So let's go back and get rid of the background 2 object. Let's get rid of it. Delete. And background 1, this one, I want to make the quad invisible for now. That's better. And I want to make the background a prefab. So I'm going to drag and drop inside my prefabs folder. So my prefabs folder is drag and drop the background. Whoop, like that. Save. Now let's add another background where we had it before. So going back to our scene again, I want to Control D and add a background. We'll call it background 2. I'd rather have them as prefabs is what I'm saying. And we'll move this out, this one here, right, this whole background. We'll move it to 10 because that's what we sized it. And now we have the effect that we want. All right, guys and girls, are you with me? So check mark if you're with me, X if you're not with me, and you know the world is a bad world, right? For Unity. I got some 7. I got half of you, it looks like. Okay, John's with me, so that's good. So again, nothing that we haven't seen before. And what does this look like? Thank you for that response, guys. What does this look like? Well, if you run this thing now here in the editor, sure, we see this, but let's take a look at what happens in the scene. The scene, it kind of resets, right? It kind of goes up and then resets. And it keeps resetting and resetting and resetting over and over again, forever and ever and ever, right? And this is kind of a one optimization pattern, if you think about it. We're preloading the background. We're preloading it in the hierarchy. The hierarchy is doing our optimization for us. Right? That's what's happening. So it's in memory, right? And it's being reused. I'm not instantiating a new background every time it resets or destroying the old one, right? I'm not doing that. Instead, what I'm doing is I'm just reusing the one that I have. Okay, this is cool. We need to add more stuff. Let's add a ship now to my background. So again, going back to my textures, I've got my pixel player ship. Let's drag and drop that into the scene. I'm going to make it twice as big. Twice as big. I'm going to move it down to a position of like minus. Let's try -4 for now. So position on the x-axis, on the y-axis, I mean -4. All right. So again, you can see that it's kind of down in here, and it looks pretty pixelated, which is what yours should look like. If your ship doesn't look like this and it looks like it's smooth or it's got like anti-aliasing, it's because you didn't do what I asked you to do. You didn't go to pixel player ship and change it to point no filter. Cool, there's your ship. I want to call this thing player. Let's add a player controller. So scripts, create new C# script, player controller. Isn't it better if it is smoother? Yes, but it would look really bad on your phone, right? This ship, the way it's been designed, right? It's more of a pixelated kind of thing, and the background looks pixelated. So if you were to add this in, and I actually increase the size of my object here in Unity, I made the size twice. The reality is, what I'd want is I'd want it so that the size of my images match my interface size, right? Because it's going to change in size. It's going to grow big and small, right? And if I was to take this to like an iPad, it's even going to be fuzzier looking and uglier. So it's better for it to be pixel perfect as much as possible, and it's not right now. We're still at 100 to 1, right? And what I mean by that is if you look at the textures, And if you look at the pixel player ship, it is the ratio pixels per unit is 100. If I want it to be 1-to-1, then I would rather make it 1-to-1 and reduce. If I did that, if I said, oh, it's 1-to-1, and if I said apply, it's going to be massive. That's how big it is. It's like a massive object, and it's really big, right? I don't want that. I want it to be 1-to-100, right? And let's get back to that player ship. There we go. But I could make it pixel perfect, and a lot of times we do with mobile games, because if we make it, especially 2D, if we don't make it pixel perfect, then what ends up happening is you have really weird effects. One thing that happens though is the scale can mess up some stuff. Okay, I want to move the ship around, but I want to move it around by pushing it around, not a fixed number. So let's add in a rigid body. So I'm going to add in, before we add our pixel, our enemy controller, or pixel, our script, our player controller. Before I add this in, let's add in a rigid body 2D. All right, so here's my rigid body 2D. And what I want to do with this is change my mass to 0. And I don't want it to be affected by gravity or angular drag. But I do maybe want to have it be affected by collision, so I'll leave this here the way it is. Awesome. And let's add the component now, which is my player controller. There's my player controller component. I'm just compressing these so that I don't have to see the details that I don't need right now. But know that we have a rigid body 2D. I should also know that my rigid body 2D is part of my character controller. So let's just go into my player controller. And at the top, that's the first thing I'll do. I'll say player public rigid body 2D. We'll call it rigid body. Maybe like this. And some people may be like, wait, rigid body, that should be this, Tom, because it's a variable name that's inside of a member function or whatever. It doesn't matter to me. You can use your own schemes. I like something like this as an example. And what I want to do is I want to drag and drop. Instead of me finding like get component, I mean, I could do this. I could say get component, right? And then I want to find the component rigid body 2D, right? And what I want to do is I want to make that my rigid body 2D is rigid body. So I can say that rigid body is equal to this. Okay? So now I've made a connection between those two things. And what I can do is I want to do very similar things to what I did with my background controller. My background controller, let's copy some of this stuff. Uh-oh, copying. That means that there's an opportunity for me to do some kind of game object superclass or something like that. But for now, let's just do this. So I know that I need a reset. Do I need a reset? Probably not. I don't need to reset my ship at all. I know I need a move and a check bounce. So those two things I need, right? It may not be the same stuff inside, so let's just get rid of this. And I do want check the right bounds and the left bounds. So check right bounds and check left bounds. I'm not going to allow players to move the ship up and down, okay, in this game, because it's like a top-down game. It doesn't make sense. So what I mean by that is the wing of the ship, the maximum it can go is like right here at the edge. It won't be able to go off screen. And the same thing goes, so notice that that's like around 1.9 something, okay? And the same thing goes symmetrically with the other side. It's about 1.9 around, right? So I want to use a boundary value of 1.9, okay? So again, what I can say is public. And by the way, this rigid body, which is never going to be exposed, could be private because we don't care about exposing it on the editor. Because, sorry, God, formatting. Yes. Okay, it's not going to let me do it until I do this. So public, we'll make a float, which is going to be called the horizontal boundary. Okay, there we go. My horizontal boundary is going to be like that 1.9 minus 1.9 thing. I'm not going to put a hard fixed value though because I don't want that to happen. Rigid body, let's rename it because it's private. So I'm going to say right click. I'm going to go to refactor, rename, and let's rename the rigid body so it's like, now again, if you're a C++ person, it's M underscore rigid body. Okay. I'm okay with that. Okay, rigid body. We know that this is what we're controlling now. It's kind of in here, right? We did use the start function, so we don't have to kill it because we're using it to get a reference to my rigid body of this object. We're using get component to do that. All right, so get component, it returns now a rigid body 2D, and that's what this ends up being, rigid body 2D. I'm in my update. I definitely want to move. So I want to move, and I also want to check bounce. I want to do that too. So those two things are the same, right? I'm going to have some kind of horizontal speed that I want to track. So horizontal boundary, public float, horizontal speed. Okay. Horizontal boundary, horizontal speed. Okay, so how do I want it to move? Well, what I want it to do is I want to change the velocity of my object. I want to change my velocity. Whenever I touch, my screen, or whenever I change positions, I want to change the position of my object through velocity changes, right? So what I want is in my move function to say something like so my rigid body, so M underscore rigid body, right, dot velocity, right? I want it equal to something that is clamped. Depending on what happens, I want it to go to a max, which means I don't want it to just keep accelerating forever, right? So that means that I also have to have a horizontal speed, maximum horizontal speed, or we'll call it max speed. Okay, whatever that is. So I want to clamp this thing, and when I move, whether it's left or right, I want to say that I want to use vector2 dot clamp magnitude. I want to clamp magnitude between my new vector that I'm creating and some kind of max speed. All right, that's what it's going to be. So I want to say that it's going to be the current rigid body velocity, right, plus some kind of new vector, right, plus some kind of new vector, right, and then followed by my max speed. So what it's going to say is I want to clamp it between whatever the velocity gives me. My max speed is going to be the maximum value. It's not going to allow me to go greater than or less than this maximum speed, clamp magnitude. All right? So I can't accelerate forever. What I want to do is add in a value in here. I just put in new vector 2, but this new vector 2 depends on what's going to happen, right? So the direction that I'm going in. So I could say something like this: if input dot get axis horizontal. It's got to spell the same way. This is using the old input system. If it's greater than or equal to 0.1 f, so outside of our dead zone, then move right. Or instead of move right, the direction is right. Direction is positive, right? Otherwise, I could say the direction is negative, but I don't want that. I want to say if get axis horizontal, on the other hand, is less than or equal to negative 0.1, then the direction is negative. Positive, negative. Okay, and that means I need a direction variable. So I'm going to say var direction, right, Well, that's going to equal to starting off at 1, right? And actually, what we can say is we can make it so that it is 0, right? So we don't add anything to the direction. We can make it so that it starts off at 0 every frame, and if we continue to push it, it'll go in one direction or the other, right? Hear me out. So if I say direction is +1 or -1, depending on what it is. Now, yes, you could probably do something with a ternary operator to some degree, but because this is not an if-else situation, because there is also a stop where I don't want it to move at all, right? That might be in here too. So direction is equal to 1.0f, and then here the direction is equal to -1. Okay, so again, it's a really slight change, right? So that is not something that typically is desirable when you have this structure, because you can kind of figure out something to do. But input.getAxis is going to present us with some issues, as you'll see. So what do we do down here now? So I want to take this direction float, or in this case it says it's a single, and that's what var does. Var kind of implicitly casts what this variable is to whatever it's the closest. The reason why it says single is because a float is in fact a single, but you can make it so you can force it as a float, and you should. So direction is a float now, 0.0f, and if I go down into vector 2, I can say that well, I don't care about the x-axis, so that stays at 0, 0, but I do care about the y-axis. So let's do that. So we'll say the y-axis then is equal to direction. And let's just hide this stuff here.
Yes, left and right.
Yes, I meant the other way around. There we go. So we don't want up and down, we just want left and right. So whatever the direction is, 1 or -1, I'm adding it on, and its maximum is max speed. Notice that there isn't I haven't used horizontal speed yet, so what to do with that? So I want to take direction, and I want to multiply it by my horizontal speed. Now you could also add delta time in here if you wanted to, okay? But I'm not going to. And to break this down, so because it's a pretty big long line, some people like to break it down a little bit. This part right here is kind of like the new velocity. That's what this is. I'm adding a new velocity vector right here. So let's just call this the new velocity. Or, yeah. So we'll say var new velocity, just to break it down, is equal to, just so you can see it all in its glory, all this. And, right, that is the, why is that not, oh yeah, we kind of missed that part. How about that? That is the new velocity, and what we can do is in the clamp area here, we can put in new velocity instead, if that makes it clear. Right, because that's what we're doing. We're going to get a new velocity, and we're going to add it in there. Instead of var, var is defining it as a vector 2. Let's just use a vector 2. And then we're going to get a change. This is going to happen every frame, every frame, every frame. That's what's going to happen. But if the velocity is 0, we're going to add in 0 times the horizontal speed, which means the velocity is going to continue to add on 0, 0, 0, 0 to whatever the current velocity is. If the current velocity is 0 in the beginning, that means I haven't moved it, it's going to stay as 0 the entire time until I press the button, until I press A or D in this case. But there's a problem with this. Check bounds. How does this work? If my transform dot position, we did this before, dot x is greater than or equal to the right bound, so some kind of right boundary, and we're going to say actually boundary value, or boundary x, horizontal boundary. There it is. We actually have that. And if that's true, if it's greater than or equal to the horizontal boundary, there we go, then we want the transform dot position to be equal to a new vector 2, vector 3 object, which is going to give us a on the x-axis the horizontal boundary, on the y-axis whatever the current position is, which is going to be, and I'm not going to set it forever, I'm just going to put it because we might move it later on, transform dot position dot y, and the z is always going to be 0 because I'm not going to change that. The z should always be 0. Okay, so that's kind of what the horizontal boundary is going to be on the right. And what if it's on the left? Well, that's the same, but instead of the signs get reversed. If it's less than or equal to the negative horizontal boundary, then it's going to be on the left-hand side. And what you want is this is going to be equal to the negative horizontal boundary. So it means it's going to stop. It's going to stop to the left, stop to the right. Okay, I'm just giving you a chance to catch up. So that's what move does. This is what this does. And we haven't tested any of this out, but we're going to try. And this is move and check bounds, and we haven't set values for these. All right, let's try this out and see if this all works. And then we'll put this up on GitHub. So, blah, blah, blah. We're going back here. It's rebuilding. Give it a sec to rebuild. Good, good, good. Horizontal boundary. We know it's 1.9. That's what we tested with this ship moving around. Horizontal speed. We got to be very careful what the speed is. Let's put a horizontal speed of, for now, 1. And a maximum speed of, like, 4. All right? Ever. And let's try it. Maybe that's too fast. Let's try this out. Should be too fast. But let's play it, and let's see what happens. And we're good, but then when I press the A and D buttons, or do one of these, I get nothing. Why is that? Because this is a touch device, even here in the editor, and we're using keyboard controls. So to test it first, let's test it in our simulator. Instead of simulator, let's test it in game, which kind of looks like this. So we can do that too. We press play. We'll fix the inputs in a second. So here it is. Look, you can see that we can move our object left and right. And we're pretty good. The one thing that's happening is we want to make sure that our object is actually above the background. And we can't guarantee that. It depends on how it renders. So in our sprite renderer, let's make sure that we have an order in layer of 1. The background has an order in layer of 0, and so does this one, 0. But the player's order in layer should be at least 1. It's the first thing in the kind of above the background, but below maybe other things. All right, let's try this out. So again, we can try it now. Does it look any better? Yeah, it looks a little better than before. Before it was confused as to which one was first. And it's not bad, but it doesn't go where I want it to go. It's like I want it to go, and then I want it to stop. It's got to stop a little faster than this. So what to do? Well, we could do what Alex normally does, which is he gets the velocity, and with this velocity, he takes he multiplies it by like 0.99. So he says something like m underscore rigid body velocity. It's kind of a trick, times or dot velocity, and then times equals to 0.99. Which kind of makes it so it continuously slows down. 99 might be too slow, or too fast. I mean, we may have to slow this down a bit more than that. So again, going back to this, and then let's save again and press play. We'll see what happens with that. So again, going back. So it's not bad. It kind of slows down, so it doesn't go forever. When I press the button, it kind of goes and it slows down, right? If I hold the button down, I can keep moving left and right, but you can see now that it doesn't go forever. Okay, pretty good. But we have a problem. The problem that we have is that we're getting input from a keyboard. We don't want input from a keyboard. Should we set the velocity as 0 if we hit the boundary? We could, but then that might mess us up, Michael. So what I'm doing instead is, look, if I press play and if I go to the right, it's going to stop anyway. It's not going to allow me to go, right? No matter what happens. It won't, even if you press it, it won't allow you, right? Cool. All right, excellent. So that's excellent, but this is not a game. This is a thing in a simulator. And again, if to show you, if I press inside here and I try and press right and left, I get nothing. And that's what's going to happen when I take this and push it onto my device. It won't work. How do I deal with it? Well, there are some other controls. Let's go to my player controller. And we need to do this, guys, because I know this is not object pooling, but we need some example that works on the device. And you need this, at least a little bit of motion to test with for your game, your assignment 1 part 2. Cool. All right, so yeah, we want to do the move, but this tests keyboard input. So our device right now, or our program, is compatible with keyboard input. If we were going to have a keyboard input as our target, let's say for, I don't know, a web game, if we're going to change this into a web game or something like that, then it would work with keyboard input. But we don't have keyboard input on a device. In fact, if anything, what we have is touch input. So how does that work? So let's go do some simple touch input, which we will update as we go forward. So it looks like this. It's like I want to get touches. So input.touches, if you notice, is what I want to get, right? Touches. There's also get touch, all right? So obtain a touch struct, all right? But touches is the actual input, all right? Input.touches. Input.touches returns an array of touches, right? An array of touches. If I want the first touch, right? And if I say that var touch is equal to input.touches 0, right? Then that is equal to my first touch. The first touch that I make. I can't do multiple touches in this scenario. If I wanted to get all the touches, then I would do a for loop. For each touch in touches, do something. So multi-touch. But I only care about the first touch that I have every time, every frame. The first touch. Cool. Well, what I have is a thing where I can say if touch.position, touch has a position. If my touch position is greater than my transform position, well, what I want to do is I want to move to the right, but I can't. They're not compatible. Notice that they're not compatible. Even if I said touch.position, this is an indicator something's wrong. Because position here is a vector 3. Position here is a vector 2. That should tell you that something's up. Because touches are on the screen space. And this is on world space. So we got to convert our screen space to our world space. So you can't just do this. Let's do it on another line. We're going to say that var world touch, that's equal to touch, but we want to do our camera dot main dot, and I want to do a screen to world point conversion. That's what this does, where I take my vector and I convert it to world space. Okay, that's what I want. Okay, this thing. Does that make sense? What I want to do? Because it doesn't make sense that that I want to so screen to world point is definitely what I want to do with the touch. But my touch in this case is a 2D vector, right? And so it's not compatible. It says argument of type touch is not assigned parameter Unity Engine 3D. Why? Because it's 2D and we need 3D, right? Okay, that's easy to solve. We can say that we can construct a new object, right? We can say that that's equal to a new vector 3 object where we pass in the again, let's do that touches to main to camera point in a second. where we say that the touches.x is here, or touch.x is here, and touch position.x and touch.position.y is a vector 3 with a 0, 0 on the z-axis, right? So that's kind of what we could do. And then what I want to do is I want to convert it so I can say that this is not a world touch. This is a, not yet. We have to do it by we're saying camera dot main dot screen to world point. We're going to do a conversion from one space to another space. Something like this. And we're going to say world touch dot position, right? My world touch dot position, we're going to compare it to my transform position. Right now, look what it says. It says my cannot resolve position. Well, because world touch is a position, right? And it says, okay, operands of type unity vector 3 and unity vector 3 cannot apply greater than to this. There is no overload for this, but I can do world touch.x and transform position.x. I can do that. Make sense? So this is if touch is to the right of the player. What am I going to do? The same thing. Now, here's what I can do. Instead of doing this and this separately, what I could do is I could combine them, right? So I can say if this or, oh God, wow, or this. If this or this is true, then we want to do to the right. So keyboard and touch input support, right? And the same thing goes if it's the other way around. If I say that if it's to the left, it's going to be a slightly different pattern when it goes on the device, right? It's not going to be the same. Unless I put my finger on the object and then I move the object around. That's different. If the object snaps to my finger, that's a different thing, right? But if not, I can do this, right? World touch, transform position at x, and this one would be if world touch is less than transform position at x. Get rid of this. So that kind of sets up some stuff for us, if this actually is true the way it works. If you give it touch dot position, the problem with touch dot position is it uses a different space. It uses screen space as opposed to world space. But are you talking about the conversion or camera dot main conversion? Converting, yeah, you can do that. So you're saying, don't do that, just do this. That's fine. Okay, so this works out okay. This is a pretty good script so far. Let's see if I'm right and if it works. So if I go back to this and if I run it now, save first, run it, we should be able to get touches. Index out of range. So what does it say? Okay, so this is a problem. It says input.touches 0. So this didn't work, right? Input that touches 0 didn't like that. Didn't like input that touches 0 somehow. Like 0, there was no touches, right? Well, that makes sense because at the beginning there are no touches, and so we can check for that. We can say that if it's true, but the problem with it is that if I did world touch, well then this would be invalidated if it doesn't exist, right? So there's another way, a fatter way to do it, which would be something that looks like this. I could say that for each, right? And we could put in, like we said, our input dot touches. For each input dot touches, all we care about is the first touch, right? Don't worry about this for a second. for every touch for the first touch, right? We want to say that we want to make it live beyond this point, all right? So we're going to say that first touch is what we want here. First touch. And we're going to put verse touch as a type of touch. So cut there, put that over here. Just reorganize our code a little bit. And that's going to be equal to a touch. Okay, so first touch is equal to touch. Like that. We're going to say that we're only going to run it. We can also, instead of doing a for each, for every touch and touches, first touch is going to be equal to touch, but if it's not, then what we're going to say that we have to do something, because this is going to give us nothing, a null value of some sort, right? So we're going to say first touch is equal to touch. And first touch is what we want here. But first touch dot position, notice it says the position of the touch in pixel coordinates. But first touch doesn't compute, right? If I said that, this is going back to what we said before, Russ. That's why I did this thing. Because then we have to go and do that new vector2 object. I don't think there's another way. You can't do touch dot position because first touch isn't a touch yet.
The problem is because you've never instantiated first touch, it doesn't know that the for each loop
I guess
will
I
get
could do a
something.
new touch. There we go. I could do a new touch and that would do it. But this new touch is going to have a. I wonder what the. I'm guessing the new position is like 0, 0, 0. My guess. Right. But we have to be careful here because that means if I stop touching it, then I'm going to get a 0 every single time. I'm going to get like it's going to actually react if I'm on the device. Right. That's my problem when I do this. If I make my first touch equal to something, then that would be a problem. And so this would invalidate this structure, is what I'm saying. I can't have a touch. I can't always assume there's going to be a touch, which means sometimes this will fail. Sometimes. It won't even compute. Like worldTouch.x might not even be a thing, right? And if I did this is my point. If I did this, I would instantiate a touch, which means I would make a touch happen. That's not good either. So this can't work. It'd be nice to know you. Thank you very much. But what we're going to do is we're going to do some duplication for now, and then later on we're going to make a method, a function to do this for us. So for now we're just going to do this. We're going to say that we just want to make it work. Remember, it's all about making it work first and testing. We don't even know if this is going to work, right? At this point. So the first thing is, can it work? Can it work? Touch.position.x. Because we don't know if it's going to actually even be a thing, right? Now this is going to work for every touch, right? Which is also not what we want, right? We don't want that at all. So let's get rid of this, world touch. And we don't want this. We want that. We want world touch actually to be our touch position, right? That's what we want. And we want this one to be world touch because we want to translate from camera to sorry, that's how it was in there. There we go. So this is going to work because for each, that means if there's none, it's going to skip this, right? And it won't affect this part because we can't combine it because the thing is we don't know if there's even going to be a touch if we want to make it compatible with mobile. If we're compatible with keyboards. If we don't care about keyboard compatibility, then that's perfectly fine. We just can assume that it's only made for, for mobile, which I completely erased the wrong one. I meant to do this one instead. All right, we're almost done. Okay, so this is pretty good. Again, now this is keyboard support, and this is touch support. So touch support is here, and we'll just put this up here because this is what this is. Simple touch input. And down in here is keyboard support. So two different things. Can we make it so that it's one? Absolutely, because we have duplication. And we can do it with a function where we pass in and say, this is a touch, or there's no touch. And if there's a touch, then do this. If there's no touch, then do that, right? But we're not doing that right now. We're just making it so it works. Remember, make it work, then refactor. Because our job today is to do object pooling, not necessarily moving. Right? That's a topic of another day. But we need to move it in order for you to show the effect, right? All right, so I think this is pretty good. Let's see how this works. So back to this. Save, run, and yeah, right? It's not bad. It works where I want to. It doesn't go as far as I want, because if I touch over here and if I touch onto it, it kind of has a funny effect sometimes the way we've done it. But it does work on the device now, right? What I may want to do for the device, for example, is change the settings on my player. So my player right now has a horizontal speed of 1. I may want to make that 2, right? And see how that looks. And we may have to play with these values a little bit, right? Okay, so it kind of increases, and maybe even a higher max speed. So make it go to 6, something like, because it's dying pretty quick, right? Because of my little trick, right? That's not bad. And now let's test it on the simulator, and then we'll save it to GitHub. So save project, save scene, build and run. You guys should be pretty much with me. Couldn't you check if input.touch.length is greater than 0? Yes, I could. Yeah, I could do that. But then what would happen is if I'm checking both things on one line, Kevin, the way I did it is I'm saying either this one or this one, and that would be bad because that means that I'm going to get a weird value, right? And that's not what I want. I don't want weird values in my. I mean, there's many ways to do this. I want to make it work right now, and then we can go back and refactor after, if we have time. All we need to do for refactoring is make a simple function that we pass in, and we say, check input or something like that. And yeah, look at that. So it kind of works okay, right? Now this is something else that is good and bad. Here's the thing. Do you want this thing to continuously move, or do you want it to stop at your finger? Like where your finger is, the last touch. And that's an effect that you want. Like, do you want this to stop where you touched? Like it's going to go and it's going to stop. The velocity is going to be 0, kind of where you're going to be. If that's the case, our 0.99 is incorrect. Let's just move this off. So that would be a different scenario. So we can use lerp for that, right? We have a beginning value and a final value, and then we can do a linear interpolation, right, of some kind. So let's do that instead. So going back to my player controller, because it doesn't quite work well with using 0.99. This thing, right? So my rigid body velocity is okay, but what I want to say is there's going to be a magnitude. My magnitude is clamping, right? And instead of clamping my magnitude the way I have it down here, can't I use a lerp? So I can use a vector2. Let's try this out. If I put lerp, I get a vector A and a vector B and some kind of t value, right? So I can say that, well, I want to go from one place to the other, but I only want to do this when there's touches. So going with what Kevin was saying, if my input.touches.length is greater than 0, I could do that. Or we could have some kind of Boolean value for now. But the idea is that we want to make it so that we want to lerp between where touches began or where the actual ship is now. So it's between transform dot position, whatever my transform position is, and where I touched. So my touch dot position, whatever that is, right, which I don't have right now. And I want to make a t value of, let's say, 0.1f. Let's just say. That is what I want to do. And that would be, here's where I'm going, or here's where I am, here's where I'm going, and this is my speed. I can multiply, I can keep lerping from one place to the other with a speed instead of having speeds and all that stuff. So this is definitely a way, right? And I'll stop exactly on my point, wherever my point was. Okay. What else can we do? Is there someone else can suggest something? Because the idea is I want to stop where my last touch was. So I could do this, my velocity, and I could check that too. I could say that, I could say that, I have a position, right? And if and only if that I have this thing going, my final touch, call it whatever you want, is where I'm gonna go, right? So I could say that for final touch, or touch's end, wherever that is, let's call it touch's end, that is of type touch. Right? Now, because I haven't instantiated anything, then theoretically this is null, right? It's null value. And here's something. Can I make it so that I can say that it's null? Can I assign it null? No. Okay, so I can't make it null. Can't do that, right? Because if I just did this, it's not nullable. So what value does this thing have if I don't do anything? If I say touch's end, right? And then the only time I want to do something, if touch's end actually exists. So I want to say, well, guess what? Touch's end is the last position, whatever my world touch is. So inside my for each, I'm going to say touch's end is equal to world touch. Well, but yes and no. So instead of doing touch's end being world touch, I don't care if it being a touch. I just need the last position, which means this could be a transform or a float, a vector. Let's make it a vector 3, just to make sure it's comparable. So touch's end then is a vector, right? And touch's end, I can't make that nullable either. I can't sit there and go, it's null. Can I? Can't do that. But I know that touch's end it's not assigned to anything, right? So I want to say that the world touch is what this is going to be, world touch, right? So it's a position. So at the end, touch's end is equal to world touch, if there's a touch. And then if there is a touch, I want to do a lerp. I'm going to say if, right, touch's end, if it exists. And notice it doesn't work like that. If I can't explicitly convert type vector to bool, it doesn't work because it's a vector and there is no conversion for this. So, and if I assume that my touch's end is not 0, chances are my touch's end is going to have something else other than 0, 0, or that's what it's going to be. So I could instantiate it like this up here, like we said before. I could say my vector 3 is equal to a new vector 3 object. That I could do. Okay? That I could do. And if I said that if my touch's end dot x, if that is equal to 0, which is almost impossible, it'd be literally impossible, right? So it's not equal to 0. If it's not 0, which makes sense, then what I want to do is I want to do a lerp. I want to do a vector 2 dot lerp from my current position, transform dot position. But we have to think about what's going to happen here for a second. Transform dot position to where my touches ended at 0.1f. The problem with this is that touches end is a local variable that's going to be rewritten every time. So we don't want this here. Instead, what we want is that to be up here. So that would be something in the space up here, which would be private. Private, vector 3, touches end. We're going to say that when we instantiate it, it makes a new empty vector. And then every frame, if it has some value, then we're good. It says equality comparison, this would be 0.0. But this is wrong because remember that we're comparing values. This is where this is complaining is we're comparing floating point values. So the only thing that when we're not going to do a vector 2, as an example, if touch's end is never modified, right? So it works for us. How about that? But it's not a great comparison. All right, so let's try this out. Yeah, blah, blah, blah. And we got this and everything else good, and we should be good. Let's see if this actually works. So, save, run. Let's try it here first. So, yeah, right? And it doesn't quite make it there in here, but what about in the simulator? Let's push it across. Build and run. Should be able to stop it now. Again, these are all, like, our controller is like super simple. Like, it's just a touch. You touch it and it goes where your finger was, right? But it also gives you keyboard support, just in case you want to put it on another device right now, right? Which is what we want, right? Because we want testing. If I want to test this on the web, or I want to give it to a friend and he doesn't have a device, you know, whatever, that's pretty good. But eventually what we want is some kind of visual feedback, like a stick, that we can move back and forth, which is what we're going to do in a couple weeks, where we kind of make a controller that's a little better than what we have right now, right? So there we go. It kind of didn't work, right? Look at that. So it didn't really do what it's supposed to do. It didn't do the lerp, right? Which means either that touches began or touch's end is not 0, 0, 0, right? And that's bad. But the lerping is not going to happen. It's not happening. So let's fix this up because I have to move on. So it says touch's end.x is not equal to 0, 0. When it's not equal to 0, 0, then we want to do this, right? But it wouldn't be equal to 0, 0 down here. Touch's end is equal to world touch, right? It's 0, 0. We're going to start off at 0, 0. Touch's end. Wait a minute. World touch is a vector 3, so is touch's end. It's a vector 3. It's just making sure. I'm going to go through it for a second. Touch's end.x is not equal to 0. Then vector 2 lerp. Transform position and touch's end. We don't care about the z-axis, so this is okay at 0.1 each. So let's see if we get in there. So we'll see a debug.log lerping. And let's see what the problem is. Okay. It says it's supposed to work. The lerping works, but what is the problem? So it gets to this, but it only gets this when I touch it, right? Because if I do it in somewhere else, it won't do this. So it says transform position is the initial position, because that's what the lerp is. Lerp vector A to vector B, and then linearly interpolates between these two values every frame. Touches end, and then transform position. That should work. That should totally work. But
we're not using that lerp thing because it doesn't actually change any of the velocity or anything.
What was that?
We're just doing a lerp, but it's not actually changing anything.
But it's changing my lerp. Yeah, it's not doing anything with it. It needs to change the velocity, like you said, or change the position. It needs to change the position, not the velocity. Velocity? No, it would be the velocity. Thank you for that. m_rigid body dot velocity is equal to lerp, right? From this to that. Velocity vector? Or would it be the transform dot position? Let's try that. See what happens. Got to think about what this is doing before I move on. All right, so that's not it. Touch's position, lerp to touch's end. Why? This is a rigid body 2D. What happened there? How did that happen? That was interesting.
The touch has an XY component, right?
Mm-hmm.
And our velocity, we're normally only doing it in the X. When we're adding a little bit in the Y, it just goes off.
And we don't want that.
Because when we touch, we can touch on the Y a bit as well. Like, all we
Yeah.
care about is the X.
We don't care about that at all. Yeah. So actually we can use a math lerp. So what we care about, we can want to do this lerp, but we want to do on the x-axis. So the velocity actually is going to be, and I don't know if it's velocity or position yet, but it's going to be something like a new vector to object, right? Where we pass in a math lerp only on the x-axis, not on the y-axis. The y-axis would stay the same. So it would be, but it wouldn't be this. I don't think it's this. Well, no, lerp. mathf dot lerp from transform.position dot transform dot position dot x to our touches end dot x. All we care about is that. So that takes care of this part, one part. And we want to do by 0.1f, that's for sure. And that's only one part of the vector. And the other part of the vector is whatever the y component was before, because we don't know where we're going to put that later. So,
Isn't the Y always 0?
no. Because y is, well, let's assume not. We're just going to plug that back in, whatever that was. Whatever we had is what we're going to get. So we're not going to mess with the y, is what this is saying. Because what if we want to take this to another, some other kind of use, right? So I don't want to put in a hard-coded value as much as possible. Like this was bad when we did this, because it might bite us later. Okay, that's not what I wanted. It's not velocity, it's, like I said, it's probably a transform deposition. Oh, wait, that's not going to work. Wait. We're going to go one way or the other way. It can't be both. Yeah. Yo. Whoa. What the heck is that, man? Right?
We're overriding all the velocity and just teleporting it eventually.
We don't want to teleport it. Let's put like another value, like 0.9. 0.9 means closer to one side than the other, right? No, that's even worse. Now there's like no velocity. Let's make a lower t value. I'm not sure if this is going to work, guys. Not the way we're doing it. I want to kind of slow things down, but I want to stop it. We can also do a boundary check. If you know the boundary check is be kind of like beyond my last touch, you know, kind of thing. But that's also tricky to do, right? That's not bad. Yeah, I like it. All right, so how does that work with, but this is only for touch, remember that. It won't work for keyboard, right? So keyboard will work the other way, right? But for touch, when we push it over to our devices, build and run, then it'll be funky, but even if it surpasses, it'll go back. It'll kind of loop us back to that position. So we won't go beyond, because it doesn't make sense from a user perspective, right? Touch something, it goes beyond where I'm going, right? So it should go to my finger. And I think that'll produce a better effect for us long term than for it to go beyond where we're going. What do you guys think? And I'm sure Russ is trying his own little tricks, you know, on moving things around because he's trying stuff that is his own, and that's perfectly fine. It's good to experiment, guys. Remember, when you submit your lab to me, I'm looking for the bullet pool we're going to make in a second, not this stuff. This is just for us to get going, which takes a little bit of time. We're going to build on this, though. We're not going to do something new next week. All right, so we can test it locally, and we can test it on the device, right? And let's see if it's actually working the way we want. It doesn't really work on the device, and that means there's a couple things. We don't know. It's not getting our current position or our touch position. Something's not really jigging on the device like it is in the editor. And that's why it's always good to test with the device as opposed to the editor. I mean, it's okay. I'm okay with this. It's just not exactly perfect. So we're going to have to come back and fix this problem. And look at that. Now it's lerping to the right. So if I said this, where is it going to go? How is it moving eventually back to the middle? This is kind of weird, right? It's going to say like, well, eventually I need to make it back to where I touched last, right? But maybe what's happening is it's so fast. It's so fast that what we have here in our editor, right? Again, in this thing, this is where the difference is between the actual device and this. If you go to our player controller for our player, right, we have a speed of 2. Maybe that's too much for the actual device. Maybe it's got to be lower, because it's overcompensating and it's going way faster than it should. Or our max speed should be lowered, something like that. Anyways, we're going to test it here for now. Let's put this up on GitHub. So file, save project. We have an initial controller, all right, which is what we wanted. So let's put this up on GitHub. I'm closing everything down in order for me to do this, because if I don't, it's going to be quite long, right? So again, going up here, I'm going to say git add dot git commit -m, and I'm going to say added player controller, or player game object. Git push. So now you should have everything that I had right now. Okay. Cool. Let's launch Unity again.
I think I solved it.
Yeah, tell me.
Just comment out all the rigid body velocity stuff. I think it's doing both at once, so the velocity is just sending it flying.
Come on. But I like that stuff so much. You don't need it.
But they're not working together. One's a rigid body velocity, the other's a transformed opposition set.
You don't need it. You don't need it at all, right? So what you could do, I like your thinking. So what you can do instead, and we have to move on, but what you can do is you can say, if this is this, then do this. Otherwise, then do this. Right? So you can do all this, right, as an example, because we won't need this at all, right? Because it's just going to lerp. Lerping is a good thing, right? And if I did this and you're saying do this, so else, if it's not this, then do this. Otherwise, don't do it, right? Would that be good? What are your thoughts? Ghost touch.
I don't know. I'd have to test it.
What? No, you have to say you're confident that Tom is right.
I mean, I commented out, put the lerp back up to 0.1 time because
it has to be 0.1,
and it works like perfectly.
Yeah, it has to be It works better this way, to be honest. But I wanted to kind of explore different things with you, things we've known before, like what Alex used to do with this stuff too, right? So, but let's try this and see what happens now. So if I go here and I run it, then, well, it's like super fast, right? Here in the device. But what does it look like on the remote? Right? It's one thing to test it locally, another thing to actually for it to work over here. Does it work like this for you?
No, mine's a little slower.
Yeah, well, mine's not slow, right? Because mine lerps, but it lerps immediately. Right? So now let's see what it looks like on a real device, because on a real device we might have a different effect. Again, basic stuff, guys. There's nothing that's going, like, you can spend time on gameplay, which is what we're kind of doing. We can spend time on gameplay for a while until it's just right. So until you get the right buttery feel of your controls. But it takes time. You have to test it, and then you have to optimize afterwards. Then you have to refactor and go, okay, how can I how can I make it so I don't have all this code? How can I reduce this code so it's nice and beautiful, right? Which was kind of what we did last week. Too much. We're not going to do that this week. All right. Yeah. So let's see what that looks like on the device now, right? Yeah. So that looks perfect on the device. It's perfect, like you said, Russ. Right. This is how it should be on the device, right? It shouldn't be. It shouldn't be like a fast, system. Wherever I touch is where this thing is going. Perfect. But on this thing, it's like really super fast, like crazy fast. Why? Because this is not realistic what's happening here. And it's much faster. Even this is faster, right? So what is the truth? Is it this? Is it the virtual machine? What does my actual device look like? Don't know. Right, but this is way fast. If you want it to be testable here, remember, we can always reduce this. And also, if you want to give some values, you might want to put it in your inspector. So something like lerp value or something like that. You may want to put in here for your, for your stuff. So expose it is what I'm saying. Instead of having it the player controller, so it's locked in here with a lerp value of 0.1, right? Make it so that we'll call this the horizontal lerp. Something like that. Public float horizontal lerp. Because guys, it's important to be able to have control, right? The more control you give people, the better, right? So put horizontal lerp in here. And it's actually not really horizontal lerp, it's the t value, horizontal t value. Let's refactor rename that. That's what it is. And we know what that is, right? So in the inspector, when we go in here, we'll see the player is going to have this horizontal t value. We can put in whatever we want. Let's say 0.1 is too much. We'll cut it down to like 0.05. So half as fast for our type of work. And then when we go back to the device, kind of thing. Then it's not as crazy fast, right? And maybe even that's too fast. We can try other values live. Right? Which is what we kind of see on the device. This is kind of what we see here. So that's where we're going to leave it at. For now, for testing. All right, so now let's do a bullet pool. I know we've been going long here, one big long recording, but it's okay. Mine's fast because maybe my Unity's fast, could be my machine. It's machine dependent, and I'm not using any kind of delta time. Delta time would make it so it's consistent, right? This is going back to what Michael said. Michael's like, can't we use delta time? Delta time makes it more deterministic, right? Here I'm making it based on my machine speed, and that's why I'm really, really fast, maybe compared to you, if my machine is faster than yours, right? All right, so cool. This is okay, but we want to do two things. One, we have a prefab. Let's drag and drop that player as a prefab. Definitely want that. And the next thing is we want bullets. So I want to make a bullet prefab. So I'm going to go into my textures. I'm going to go into bullet and drag it in. Let's make the bullet what it is. First of all, the bullet's really, really small. So let's make it twice as big. So twice as big. And we also want to add a bullet behavior or bullet controller. So let's do that. So we're going to go into scripts. And we're going to add a new C# script. We're going to call this bullet controller. Here's my bullet controller. And we want to add it in. Okay. And how the bullet controller is going to work, let's just test it. So I'm going to go to my scene, and I'm just going to pull my bullet down towards my ship. So something like this. This is where it's going to start. And what I want is when the bullet starts, it's going to go up, right? A certain speed. It's going to be consistent speed in this case. So here what I'm going to say is we're going to do a move and a check bounce. So going back to what we already have, we have move and check bounce, but we have a simpler one over here that we're going to take from our other thing. So I don't want to duplicate code but notice we're using move and check bounce a lot because that's the way we're doing it. So maybe there's a way, of having a superclass that does maybe an actor class, because we have move and check bounds a lot. If we have the same methods over and over again, it makes sense to add something like that. So we're definitely going to move our bullet, and we're going to definitely check bounce. The way we're going to move our bullet is we're going to say transform.position. We're going to move by position, not by we're not going to accelerate it, right? So that's going to equal to the speed. So we're going to have a bullet speed. We'll say vertical speed, so float, and public float, vertical speed, right? And whatever that vertical speed is, we're going to add on to it. So we're going to say plus equals to a new vector 3. On the x-axis, it's going to be 0, 0. On the y-axis, it's going to be vertical speed, right? Positive vertical speed upwards. And on the z-axis, it's going to be 0. So that's what's going to happen with the bullet. The bullet's just going to cruise along, up, 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 up. It's going to keep going. And how does this work? Does it work? Well, let's try it. So going back to this, and we're going to go play. And what happened? Did it get connected? Do we have bullet? Oh yeah, the vertical speed is 0. So let's add a vertical speed of 0.01. That's pretty good, right? So 0.01 seems to be the right value. Let's put that in there, 0.01. And when we play it again, we see that the ship would fire. If it was a single bullet, boom, that's what it would look like. All right, so bullet looks like it's pretty good. Prefab time. Let's move this into a prefab. Boom, prefab. Get rid of the bullet from here. Cut. Delete. All right, now we need a firing mechanism, but we're not going to make it from the player. The player is not going to hold the bullets. We're going to make a bullet manager, right? Or a game controller that controls everything. Let's call it, in our case, because we're making bullet pools, a bullet manager. So again, right click, new empty object. We're going to call this bullet manager. Our bullet manager is going to have a script, which is in our scripts. We're going to call this bullet controller. We'll call bullet manager. We have a bullet controller. We could have called this bullet behavior. And what we want to do is we want to connect our bullet manager script to the bullet manager. There it is, connected. Okay, how does this bullet manager work? Well, first of all, we want to have a couple things exposed. We want a reference to the bullet. Right, so we're going to say that public game object bullet. We also want to make a private queue, right, which is of type game object. We're going to call this bullets. Remember we said queue, not list. So bullets, and we can call this, to be fair, bullet pool. If it's private, let's call it m_bullet pool. Because we're never going to see this exposed. m_bullet pool. Let's instantiate it here. We want a couple things here. One, we want a build bullet pool private _build bullet pool method, which is going to return void. Okay. We're going to call that in start. So build bullet pool. And in the build bullet pool method, we're going to say, okay, well, our bullet pool is equal to a new queue of type game object. So this makes the structure. So create empty queue structure. Now sometimes Unity will do this for you, whether you do this new part or not. This is required in normal C#. You need to have it, but in Unity sometimes it'll just make it for you. But I want to make sure it's there, and also I want to make sure it gets wiped away when I need to. All right. Next, I want to create maximum bullets, some kind of thing. So we have a bullet game object, and we want public an integer max bullets. We'll call it max bullets. So we're going to say for, we're going to do a for loop, for count is equal to less than max bullets, right? What we want to do here is we want to add or queue a new bullet. So the way to do that is, first we need a temporary bullet. So we're going to say var temp bullet is equal to instantiate, right, a new bullet object, right? And what we want to do when we instantiate is we want to set the temp bullet active, set active to false. Remember I said this? You make them all false first. And then after you make it false, then you on queue it. So we're going to say bullets, no, bullets dot on queue. Now why isn't it coming up? Oh, bullet pool. I call it bullet pool. Bullet pool dot on queue temp bullet. All right, so let me go through this again. So first we instantiate an empty, like kind of an object of type bullet, right? Then we set it to false, so it's not active anymore. Then we put it inside the bullet pool. When it's set to false, you can't see it. It's invisible. It's not in the scene anymore, right? We put it in the bullet pool, which is a queue. We on-queue it. Okay, that's what we do. And we do it max bullets times. So 50 times, let's say, as an example. That builds our pool. Once our pool is built, what we want to do is we want to create methods in order for us to get bullet and set and return bullet. So let's make two public methods. One public method which is called, it's going to return a game object, and we're going to call it get bullet. But we also want to know where to return the bullet. So we're going to pass in a vector3 position. We want to know where to return the bullet. This is important. And what we're going to say is, I want to dequeue my bullet that I want to get. So I'm going to say again, var, new bullet. We'll call it new bullet. Right? We're going to say that that is my bullet pool dot dequeue. Right? And what dequeue does is it takes the member at the front, the element at the front of the pool of the line, and return it. It returns a reference to it. That's why queues are perfect for this. And then what you do is you say new bullet dot set active to true. So it becomes in the scene, goes in the scene. Okay. And the next thing you want to say is I want my new bullet dot position transform dot position equals to the position of the whatever we feed it. Right, so that's what this is. So we've set up our bullet, and now we return it. Return back that bullet. New bullet. Make sense? So that is our get bullet function. Okay, so again, we pass in a vector3, a place to make it. First we built it in the pool, then we return it out. We remove it literally from the pool. The pool doesn't exist. It doesn't have it in the pool anymore. Okay. Next, we want to be able to return it back into the pool. So we're going to make another public thing, which is going to be void, and we're going to return bullet. We can also add bullet or set bullet, whatever you want to, if you don't like return bullet. But I want to return a bullet, and it's got to be the type is game object that we're going to get bullet. We're going to say, we can also call this returned bullet, just so there's no clash between bullet up there and bullet down here. Here's a return bullet. So what do we do now? Well, return bullet dot set active to false, right? We modify it on the way in, right? And we don't care what the last position was. We just know that it was false, and we want to re-queue it, on-queue it again, right? So we're going to say bullet pool dot on queue return bullet. This puts it back into the pool. So we have a get bullet and return bullet. These are in fact setters, getters and setters. But anyways, are we good so far? I lost a few people, but it's okay. Check mark if you're good, X if you're not good. Okay, a few people said yes. Some people are just watching. All right, I'm going to continue. But there's a problem with this, right? Because I need to have access to Bullet Manager somehow, right? So let me talk about this. We're not going to do an update, so Bullet Manager is not going to have an update. So let's kill this. We don't need the update function right now, because all Bullet does is it manages bullets. That's all it does, right? And what I want to do here in my Bullet Manager, my max bullets is 50. Okay, but I want my player controller to know about Bullet Manager. I'm going to say, hey, Bullet Manager, give me a bullet. So if I go to my player controller and let's make a reference to Bullet Manager, I'm going to say, okay, Bullet Manager, public. We're going to say Bullet Manager, right? And we'll call this Bullet Manager. Cool. And I make a reference to it. So in my player controller, I have Bullet Manager and I pull it in. No problem. Now we would have to save my prefab, override my prefab again because I modified my bullet player prefab for this. It's okay. Here it is. Wonderful. But there's a problem. If I say every frame I'm going to fire bullets, right? So here I'm going to fire bullet every frame. It's continuous fire, all right, that I'm going to do. So I'm going to say fire bullet, right? Fire bullet, and let's make that. Here's my fire bullet method. What will it do? Well, I need to say, hey, Bullet Manager dot, right, get bullet. That's what I want to do. And I want to get my bullet, which is at my position. So transform dot position. And maybe what I want to do is I want to make not just my transform dot position, but some other value. For now, we're going to make it go on top of me. To guarantee that I have access to this function, to get bullet, a lot of times what I want to do is in my Bullet Manager function, my Bullet Manager class, I want to serialize it. I want to make sure that I have access. So I want to say system.serializable, which is going to expose Bullet Manager to the entire project. Okay, that's an important step. Sometimes you do not have access to it. Remember, this is not instantiated. It only gets instantiated in the hierarchy, right? So we may have a disconnect. So that's why I want to do system.serializable. So in my bullet controller now, or my player itself, my player controller, I get a bullet, and that's from the Bullet Manager, right? As soon as I get a bullet, it returns a bullet to me, right? I don't have to do anything with it if I don't want, right? Because it's just going to return a reference if I want that bullet, if I want to control that bullet for whatever reason, okay? For now, I don't need to. I just do this. But later on, maybe I want to control the transform. I want to make it different colors. I want to make it collide. I want to check the, whatever. For now, I don't care about that. And then, okay, fine. It fires it, but the problem is my queue will eventually become empty. Let's take a look. So if I go back to this, and if it worked, let's see how that works. I want to say, well, oh, by the way, here's something else. My Bullet Manager, let's go back to that. Bullet Manager has no idea what bullets are. So let's pull that in from the prefab. That's important. I need to pull it from the prefabs list. I need to pull that bullet into my Bullet Manager, or else I won't be able to make bullets. Okay. Let's also reset the Bullet Manager so it's in the middle of the screen. I don't care. It's not going to show, but I'd like to reset my empties, right, if I have to. Cool, so there's my Bullet Manager in the middle of the screen, and let's see if it works. So I should be firing immediately. Oh man, and it's gone, and you can see that it just spat it all out, and it's all gone. So I need to slow that full bullet firing down. And the way to do that is, I'm going to say that, well, if time dot, and I really want a frame count. If my frame count percent 20, let's say, well, I'll make it even slower. 40 is equal to 0. So once every 40 frames, then and only then do I want to spit out a new bullet. Right? Because that's going to save me some things. It's going to make it a little better than what I had. So this is kind of like a delay, if you will. So delay bullet firing by 40 frames, or every 40 frames. Right? All right, cool, cool, cool. And let's run it, kind of thing, and see what happens now. Right? So that's not bad. That's not a bad stream. But then eventually it's going to run out. Right? That's a problem. Yeah, the layer, it definitely should change the layer. So that's another problem. So the bullets right now by default, its order and layer is 0. Let's make my order and layer either the same as the ship or below. If I want to do that, my player should be maybe at order and layer of 2. And if I want to, I can make my bullets. Let's save that, apply to all. And let's get my bullets and make them order and layer of 1. So that way they're below my ship. They'll seem to come underneath my ship. Right? All right, let's try that again. So run it, and you can see now it's going to be underneath my ship. Right? Looks like it's coming from underneath my ship, but then it's going to run out. We don't want it to run out. What we want is for it to kind of go back in. So we don't put it back in. We don't track the bullet. The bullet tracks itself. So what we want is for the bullet itself. Here's my bullet. I want to go to my bullet script, my bullet controller, and I want to get a reference to my bullet manager again. So I'm going to say, hey, bullet manager. This time I can't drag and drop because it's a prefab. So what I need to do instead is I'm going to say bullet manager dot is equal to find object of type bullet manager. So I'm going to get a reference to my bullet manager by finding the object of type in the scene. That's what this does, because I can't drag and drop. Like if I made it public bullet manager, but there's no way for me to go to my prefab here and in my bullet and drag and drop a bullet manager here. Watch, if I do this, it just won't work. Right? It says no, can't do it because this is a prefab. And it may or may not be in the scene, so it'll fail every single time. So the only way it can detect the bullet manager is when it's in the scene, it's going to find the bullet manager. And that's how you do it. You go bullet managers, you go find object of type. We search for a bullet manager in the hierarchy, and the first one is what we take. Hopefully there's only one. Cool. Check bounds. We left this empty for a reason. We're going to say, okay, if transform dot position dot y, if the y-axis is greater than, we're going to say 10.0f. If it's left the screen somehow, right? And again, I'm guessing it's 10. It could be 5. Upper boundary. We're going to make it so that there's different things. We can test this, right? In a second we will. But what we want to do is we want to say, hey, bullet manager, I want to return bullet, and I want to return this game object. So I'm going to say game object. So this dot game object is what I'm returning, not my script. This is the script. I want to return the game object that this script is attached to. So I'm returning game object. So that's what this does. So this sends it back. But I don't know if 10 is the right value. And it's going to be the upper boundary for this thing. So I'm going to say the horizontal boundary. Notice the similarities. Horizontal, or sorry, the vertical boundary. Vertical boundary. And vertical boundary is going to be a float type. I'm going to take this value and we're going to cut it and put it underneath the vertical speed just to make it the same. Again, there's lots of optimizations here we can make, but we're running out of time, and we want to put this vertical boundary here, whatever that's going to look like. Okay, so check bounds is going to happen, no problem. Go back to my my bullet then. What is the vertical boundary? Because my vertical boundary by default Here it is, vertical boundary. We don't know what that is. Let's put a bullet in play, and let's see where that would be make the most sense. So I'm going to get kind of here. I'm going to go here into my scene, and I want to detect when this is off screen. So something like this then, right? Which is like 5.11, right? Like I want to make it so that as soon as it's off screen, I want to get it. 5.14, something like that, right? So maybe something like, I don't know, just a little bit outside of screen, like here. So make it like 5.2, something equal, right? Or even. So 5.2 looks good. Let's delete that. And in my bullet, that's going to be my vertical boundary. My vertical boundary is going to be 5.2. All right, finally, let's get back to it and let's do it. So we're instantiating bullets, and notice that they go out of active, and they go back in, and they go back out. Isn't that interesting how that works? Look at that. How they are active and then they become inactive, and they're active and then become inactive. And if I move my guy around, it's going to look like how it should look, like a rain of bullets, right? One last thing, an optimization that I want to make is that bullet manager should have all the bullets underneath it. So when I instantiate my bullet manager, my parent transform is going to be bullet manager, not out in the open up here. So I'm going to make it so that bullet manager has all the bullets that come up, and it's going to be, they're going to come up as children. All right. So how do we do that? So say when I'm instantiated, right? That means when in my bullet manager itself, I'm going to say that when I get my bullet and before I return it, right, I'm going to say that, yes, bullet transform position is equal to position. That's wonderful. But what I want is that my transform dot parent, so new bullet dot transform dot parent, right, is equal to transform. So what the heck is this line? This says that the parent of my transform is me, which is the bullet manager itself. So that means that I am going to be a child. When I get created, I'm going to be a child of my object. And I don't want to do it here. I want to do it when I create it here. So I want to say that temp bullet then is going to be a transform of my parent, this object here. Transform parent is going to be this object. Let's see how this works. So if I go back and I run it, then now notice that we still have the same thing, but the bullets are in here. They're inside of bullet manager. There are children of bullet manager, so it doesn't clutter our hierarchy. Otherwise you're going to have a bunch of like these bullets running around, or enemies, or pickups, or whatever, right? And Michael says, when did I call fire bullets? I called it inside of my player controller. So fire bullet is here, and it's going to be fired every frame the way I have it. I'm doing it so that I frame count %40 is equal to 0. So I check to see if it's every frame or every 40 frames, and then I get bullets here. When I get bullets, I don't do anything with the bullet. It just actually, the reference of it goes missing. I don't care, right? If I want to do something, and I will in the future, then I have reference to it. Right now, I don't need it. So that should do it. Yeah, it's got to be on update, because otherwise it won't keep firing, right? It's got to happen every frame. So again, now what we have is this, where I kind of run and I go to the right and left, and it looks pretty good. But the problem with this, and if I'm just holding my finger back and forth, it looks pretty good, right? So I can kind of do one of these. My problem with this situation is that, first of all, let's change my player's motion back to what it's supposed to be. So instead of my horizontal t-value being 0.1, let's make it 0.1, like this, 0.01. And let us save the scene, let us save the project, and let's kick it over to our device, because we should test it on the device, and then we're done for today. So to finish off, when you hand in your lab for this week, right? again, what I'm looking for is this, what we talked about. We actually did two optimizations. A reusable background scrolling background, that's what we did. And the other optimization is a bullet pool. And we use the bullet manager for this to happen. Now this bullet manager or object pool is something that we can use as an example for explosions, for sounds, for pickups, for enemies, an enemy manager, an explosion manager, a pickup manager, whatever manager. And you can have different pools of different types. But you pre-instantiate everything is the idea. Well, look at that now. So you can see that there's issues, right? It really fires slowly. Like this is way too slow here for the bullets on the thing. So you can see that the bullet firing on the VM is really slow. But what is it really like? Don't know. I'd have to have a real device for this. But it's working, right? It's just like super slow, right? It's super duper slow. So one more thing. Let's just one last optimization. Bullets should be at least twice as fast. So vertical speed, just like we did before, is like 0.1. Right? So save. Let's do one more push across. Build and run. Again, this is based on my frame rate compared to the frame rate that I'm getting on my machine. I haven't limited them by delta time. So this is why I'm getting this really weird error. If I limited it by delta time, like Michael was saying, then chances are what would happen is it'd be better. Why not put the transform in instantiate? What do you mean by that? Are you talking about like the transform parent?
When you instantiate, when you instantiate the object, you give it the prefab, and then you can give it the transform for its parent. So you don't have to set it anywhere else.
That's acceptable. I just wanted to break it down over different lines, so you can see. You can also do everything else with it. You can give it position too. Okay, that's not terrible. It's still not as fast, but look at that. That's how it works in the virtual machine. But you get a sense of what's happening here, right? That's the idea. It says 60 frames per second, so I mean this would be on pretty good on a regular machine. Chances are. And again, maybe what's happening now is I have to speed up the number of frames. So, and when my bullet fires, let's go back. When my player, last change, I swear, then I'll stop. So if I go to my player controller, instead of every 40 frames, it's every 20 frames. You know, as an example. And then, again, I would do the same thing. I would just push it across and see so you can test that, build and run. But the challenge, the reason why it's different is because my machine speed, my actual machine, is way faster. I mean, it's not frame limited at all. I can go as fast as I want, right? Whereas my device can't handle that kind of speed. There's no way it can handle, I don't know, 120 frames per second or whatever I'm running. I mean, my specs are going to be way different than my virtual machine, right? So that's the thing, and that's where you multiply it by delta time. And so you can limit how fast your frames go, frame limiting. The other thing you can use instead of update, you can use fixed update, which also might help. So let's try that out again. Here it's really, really fast, like super fast, right? But on the device, right, when we look at what this looks like, it's much better, right? And you can actually drag your finger around and it'll work, right? Because whatever the last position of your finger is, if you just hold it down and move instead of clicking, you can click, or you can do this, just hold your finger down. That's not bad. All right, bullet pools and the bullet pool manager. All right, so that's what we kind of did today. I'm going to file, save project, and kill this whole thing, and then put it up on GitHub. And guys, we're done for the day. Any questions before we go? Anything that boggled somebody, or Russ? Is that still your question from before? Or is that something new?
That was from before.
Okay, sorry about that. Git add dot, git commit -m, and we're going to say added bullet manager. Git push. Okay, so that's your bullet pool or your object pool. All right, in terms of learnings, anything new for you guys that you've not seen before. I know you're learning stuff with Joss, and Joss may be showing you that kind of stuff as well, but he may not exactly in the same way. So I'm hoping that you have a chance to see some of the same stuff. Anything new? How are you feeling about that? Again, also, I do things differently than Joss. Michael says lots was new for me. Russ, you've done this all before, so it's not a big deal. Anyone else? Any feedback before we stop for the day? New to me, doing the pool way. Cool. Okay, good. So there's some learnings involved. And this is, again, optimizations for mobile to make it work a little bit better. And you can see I was running at 60 frames per second on my machine, right? So it's not terrible, right? All right. That's it for me. Thank you so much for sticking around, guys. Make sure you hand in Lab 3 by the end of the week. So I've made it due by Friday, midnight, which gives you a couple days to clean it up and test it and try it out and watch the video again, all that kind of thing. And make sure you start off as soon as possible with Assignment 1, Part 2, as I don't want it to clash with what's going to happen in your mid-semester break, or mid-semester midterm exam, okay? Otherwise, that's it for me, guys. Thank you so much, and I will see you guys next week. Ping me on Discord if you need me, all right? I'm going to stop this recording, and then I'll see you guys next week.